Alright, so in this problem we got the wheelchair marathon problem. Um, they're comparing female wheelchair times versus male run times for every year in the New York Marathon. So for the last 28 years here. So I guess that goes, I guess they started in 1977 and went up 28 years and just did it every year. So again, they paired the samples, so this is a match paired t-test. So they want us basically to do a confidence interval. So our parameter here is the difference. Mu of d is the mean difference in times between women wheelchair and male runners. The assumptions and conditions here. Is this a random sample? No, it's not random, but it's representative. So this is a representative sample. This is a matched pair. It's not independent samples. This is 28 is less than 10% of all samples. And since n equals 28, we're gonna say it's safe because it's not a single digit sample. I know it's not 40 or more, but it's a fairly large sum. So it's safe to proceed because of the central limit there. Okay. The name of this test is going to be a matched. Let's try that again. Matched pair confidence interval. Okay. And in this case, we know that n is 28. We know that x bar sub d is 0.089286. And we know that the standard deviation of the difference is 37.7241. Okay. Okay, the interval itself, we're going to do x bar sub d plus or minus t with 27 degrees of freedom times the standard deviation over the square root of n. Okay. So we're going to do 0.089286 plus or minus. Now we're doing a 95% confidence interval, so that means if we shade in 95%, that means that there's 2.5% in each tail. So that starts at the 2.5 percentile and it ends at the 97.5 percentile. So I'm going to go to my calculator and I'm going to get that t value. Okay, so second distribution, inverse t, 0.975 with 27 degrees of freedom because it's just n minus 1. If we do that, we get 2.052. Okay, 0.052, and then we're going to do 37.7241 over the square root of 28. And then I'm going to go to my calculator and I'm going to go to stat test and I'm going to go to t interval. Alright, so and I'm going to push stat. I'm not doing data, I'm doing stats. Okay, so my x bar here is 0.089286 and my standard deviation is 37.7241. My n is 28 and my confidence interval level is 95. And that's our interval. So we get negative 14.54 to 14.717. Okay. Okay. So that's our interval. Okay, now if you look at the problem here, right here it says the wheelchair times minus the run time. So the wheelchair time, we subtracted the wheelchair times minus the run times. Okay, so the conclusion is we are 95% confident that the difference, the mean difference, between wheelchair times and run times is that women is between about negative 14.54 minutes and positive 14.72 minutes. Okay. So again, this is confidence interval is for the difference in those two times. Okay. So that's basically what we're going to write it as. So what that means is there's no clear evidence that the women were faster than the men because 0 is in that interval. Okay. So that's what our conclusion is. And then now, if we did a hypothesis test, would we wind up rejecting it? Well, the answer is no, because if we were, then what would happen is we wouldn't have had 0 in our interval. Okay, so we wouldn't reject this at the 0.05 level. Now, remember, a 95% confidence interval, you had this would coincide with a two-tailed test. So you would say that, right? And you can test it yourself. Just go to t-test. But you're not. There's t-test and there's our stats. So what's our difference? Our difference 0, and we're going to go to not equal to, and everything else is in there. X bar, standard deviation. So if we draw that out, I can tell you right now we're going to get a p-value over 0.05. Yeah, our p-value is 0.99. So we clearly are not going to reject here. So there is no evidence of a difference in the times of wheelchair runners and male runners.